Imagine you're managing several applications, each with its own requirements. One needs Windows, another needs Linux, and yet another must be deployed in the cloud. How do you keep everything running smoothly? Do you use virtual machines for full isolation, or is it better to go lightweight with containers? The answer isn't as straightforward as it might seem. Keep watching to uncover the hidden differences that could change the way you deploy your applications. Virtual machines, or VMs, are great when you need to run different operating systems or when you need strong isolation between workloads. Containers, on the other hand, are ideal when you want to deploy apps quickly, at scale, without the overhead of managing full operating systems for each app. Now let's break down how these technologies actually work. Virtual machines are a way to simulate an entire computer system. Here's how it works. A hypervisor is a piece of software that sits between the physical hardware of a machine and the operating systems running on it. The hypervisor divides the physical machine into separate virtual machines, each with its own full operating system and virtualized hardware. The hypervisor manages how resources like CPU, memory, and storage are allocated to each VM. Since each VM is running a complete operating system, it is isolated from others. Each VM behaves as if it's running its own independent hardware, even though it's actually running on shared physical hardware. With VMs, each environment is entirely independent. This gives you machine-level isolation, which means the software in one VM can't interfere with or see the software in another VM. This makes it an optimal choice for highly secure or resource-intensive applications. So at a high level, when do we use VMs? When we're running apps that require multiple operating systems, or when you need strong isolation between workloads, such as for security or compliance reasons. Now let's talk about containers, which is an alternative approach that's much more lightweight and efficient. With containers, OS-level virtualization allows multiple applications to run on the same operating system without needing separate, full operating systems for each app. Instead of simulating an entire machine, containers share the host operating system's kernel, the core component of the OS that interacts directly with the hardware. Each container, however, runs in its own isolated space with its own set of dependencies, libraries, and processes. Even though containers share the same kernel, they use namespaces and control groups, or cgroups, to keep processes isolated. Namespaces provide an isolated view of the system for each container, so each container believes it's the only one running on the system, even though it's not. This is how containers achieve process-level isolation, isolating each app without the overhead of a full virtual machine. Cgroups allow the system to manage the resource usage of each container. And by using cgroups, containers are allocated specific amounts of CPU, memory, and I/O, which ensures that they don't interfere with each other. Containers are extremely fast to start because they don't need to boot up an entire operating system like VMs do. Instead, they just launch the application and its dependencies. Okay, so when do we use containers? We use them for cloud-native applications that need to be scaled rapidly. Or when you need to deploy microservices efficiently. They're also ideal for use cases when you want a more lightweight approach with faster startup times and minimal overhead. Let's compare these two technologies in terms of isolation, resource usage, and startup speed. VMs provide machine-level isolation. So each VM is a completely self-contained environment with its own operating system and kernel. And this is what makes VMs ideal for highly secure and isolated workloads. Containers provide process-level isolation. They share the host system's kernel but use namespaces to keep processes separate. And containers are isolated at the application level rather than the machine level, which is why they're more lightweight. In terms of resource usage, VMs require more resources because they run full OSs and virtualized hardware, and as a result, they are more resource intensive and slower to start. Containers are far more efficient because they share the host system's kernel and use fewer resources, so they can run many more containers on the same hardware. And finally, startup speed. So VMs can take several minutes to boot up since they load a full operating system, while containers can start almost instantly since they only need to launch the application and its dependencies. The question is, what if you need the best of both worlds? Many organizations run containers inside VMs to take advantage of both technologies. The VM provides security and isolation, while the container gives you efficiency and speed. This combination is especially useful in environments where you want to manage different workloads and ensure security at the infrastructure level, but still want the speed as well as the flexibility of containers for app deployment.